Time. A concept so deeply woven into our lives that we barely question its existence. The ticking clock on your wall, the calendar on your desk, the very essence of before and after. What if it's all an illusion? Buckle up, because the James Webb Space Telescope, the marvel of modern science, has unearthed something so profound it challenges the very fabric of reality. Yes, you heard it right. Time might not exist as we think. And the implications? Absolutely earth-shattering. But how did we get here? How did a telescope floating 1,000,000 miles away in the cold depths of space manage to shake the foundation of physics and philosophy alike? Let's dive into this cosmic enigma and unravel the jaw-dropping evidence that has left even the brightest minds scrambling for answers. To understand this revelation, let's first look at the James Webb Space Telescope, JWST, humanity's most advanced eye in the sky. Think of it as the Hubble telescope's cooler, more powerful sibling. Launched on Christmas Day 2021, this engineering marvel has been stationed at the Lagrange Point 2, a sweet spot in space where Earth's and the Sun's gravitational pulls are perfectly balanced. Why is JWST such a big deal? Its infrared instruments allow it to peer deeper into the universe than ever before, capturing light from galaxies formed mere hundreds of millions of years after the Big Bang. Essentially, it's a time machine, letting us look back billions of years. But what happens when this cosmic time machine starts sending back data that doesn't align with our understanding of the universe? Okay, so let's break this down. The James Webb Space Telescope captured signals and light patterns from some of the most extreme places in the universe, around black holes and supermassive gravitational fields. And something weird happened. These patterns didn't behave like we'd expect them to. In fact, they defied the laws of physics that we've trusted for centuries. Now this is huge because, in physics, time has always been seen as a fixed dimension, a constant that we can measure and observe. But these new findings suggest something far stranger. In areas with intense gravity, near black holes for example, time doesn't just behave differently, it appears to break down entirely. So, if time doesn't work the way we think it does, then what's going on? Is time just a clever trick our brains play on us to make sense of the world? Could it be that time, as we know it, doesn't exist at all? You might be thinking, this is insane. How could time not exist? Well, this might be where things get even stranger. This idea isn't completely new. In fact, it ties into something that quantum physicists have been hinting at for years. Quantum mechanics tells us that the laws of physics in the quantum realm, where particles are incredibly tiny, don't follow the same rules we see in our everyday world. In the quantum world, particles can exist in multiple places at once, and they can instantaneously affect one another across vast distances. This is called quantum entanglement. It's almost like the normal rules of time and space don't apply here. So, what if time is just a perception? Maybe the universe is more timeless than we've ever imagined. Maybe our sense of time is a fabricated experience, something our brains conjure up to keep us grounded. For decades, the Big Bang Theory has been the cornerstone of modern cosmology. It posits that our universe began as a singular, infinitely dense point around 13.8 billion years ago, followed by an explosion that set everything in motion. The theory also asserts that the universe has been expanding ever since, like a balloon being inflated. Yet the JWST's findings have thrown this widely accepted narrative into disarray. Let me paint the picture. The telescope's first images showed galaxies that are smaller, older, and more numerous than they should be, given the timeline of the Big Bang. How is that possible? Imagine you're expecting to see baby pictures of the universe, tiny, chaotic galaxies still finding their shape. Instead, JWST reveals fully formed, smooth, spiral galaxies akin to grown-ups strutting confidently across the cosmic stage. One such galaxy, nicknamed GHZ2, is so small it should be a mere speck. Yet its brightness and density make it 600 times more luminous than the brightest galaxies in our local cluster. It's like finding a grain of sand that glows brighter than the sun. Now, here's where things get even weirder. These findings suggest that the universe might not be expanding as we thought. If that's the case, the very concept of time dependent on an expanding universe starts to crumble. Think of time and space as a stretchy rubber sheet expanding with the universe. If the sheet isn't stretching, does time even exist? Or is it merely an illusion, a construct of human perception? This notion isn't entirely new. Theoretical physicists, including Albert Einstein, have long grappled with the idea that time might not be fundamental. Einstein's theory of relativity links time to space, creating the famous concept of space-time. But if the JWST data challenges the expansion of space, does it also undermine time? Let's pause for a moment to consider what this means for us here on Earth. If time is an illusion, what about the way we live our lives? Deadlines, aging, the inevitability of death, all of it hinges on our understanding of time as a linear progression. Could this discovery mean that the past, present, and future coexist in some grand cosmic tapestry? It might sound like science fiction, but some physicists have proposed that time is more like a landscape. In this view, events don't happen to us. Instead, we traverse them, much like hiking through a mountain range. Let's go deeper into the JWST's findings. One glaring anomaly is the redshift of distant galaxies. In an expanding universe, light from galaxies moving away from us stretches, shifting toward the red end of the spectrum. But JWST's data shows galaxies with redshifts so extreme, they seem to defy this explanation. Some scientists argue that redshift might not indicate motion at all, but rather distance. If true, it further undermines the idea of an expanding universe, and by extension, time as we know it. Another head-scratcher? The age of stars in these distant galaxies. If the Big Bang occurred 13.8 billion years ago, how can some stars in these galaxies be over 1 billion years old? It's like discovering fossils of modern humans in a timeline that says dinosaurs still ruled the Earth. Let's address the elephant in the room. If time doesn't exist, how does it change our understanding of reality? Philosophers have pondered this for centuries. St. Augustine, for instance, once said, "What is time? If no one asks me, I know. But if I wish to explain it, I do not." Modern scientists like Carlo Rovelli have echoed this sentiment. Rovelli, in his book The Order of Time, suggests that time is not a fundamental aspect of reality, but an emergent property, a way for us to make sense of the universe. If JWST's findings validate this, it could revolutionize not just science, but philosophy, psychology, and even how we live our lives. Now, let's inject some levity into this mind-bending discussion. One popular theory to explain these small, dense galaxies was that they collided with each other over billions of years, merging into larger galaxies, like cosmic bumper cars. But guess what? JWST squashed that idea too. Its high-resolution images show pristine, untouched spiral galaxies with no signs of the chaotic wreckage you'd expect from galactic fender benders. So, what's next? The scientific community is in a frenzy, debating whether to cling to the Big Bang theory or explore entirely new models of the universe. Could the JWST's discoveries pave the way for a new understanding of reality, one where time and space are no longer the final frontiers, but merely illusions? In the words of Michio Kaku, Science is the engine of prosperity. It opens the mind to new possibilities. JWST has opened a door we never knew existed, and stepping through it might change everything. As we ponder these revelations, one thing is clear. The universe is far stranger and more beautiful than we ever imagined. Whether time exists or not, whether the Big Bang is history or fiction, one truth remains. We're just beginning to scratch the surface of the cosmos's infinite mysteries. So, stay curious, question everything, and remember, the James Webb Space Telescope isn't just looking out into space, it's looking back at us, challenging the way we see ourselves and our place in the universe. And with that, we leave you with this tantalizing thought. If time doesn't exist, are we all timeless beings, forever part of an eternal now? Until next time, or is it now? If you enjoyed this video, don't forget to give us a thumbs up and share this video with fellow space enthusiasts. Your support helps us continue exploring the wonders of the universe. Be sure to subscribe to SPACEEFIED and hit that bell icon so you never miss an update on our latest discoveries. Dive deeper into the mysteries of space by checking out our other videos, and let's keep the adventure going on together.